Hi Grade 8, I'm Teacher Joshua, your mathematics learning guide here at DepEd TV. Do you still remember how to find values that would satisfy an equation? This time, let's discover another way to see solutions of a particular kind of equation. Working together has been one of the values being instilled in us even when we are still young. Anna and Ben volunteered to bring chairs for the charity program. They were asked to bring in a total of 10 chairs. How many chairs did Ben bring if Anna brought in 3 chairs? If Ben brought in 4 chairs, how many did Anna bring? How many chairs did Anna bring in when Ben brought 9 chairs? We can set up an equation to these situations. Let x be the number of chairs Ben brought in, and y be the number of chairs Anna brought in. If they brought in a total of 10 chairs, we have an equation x plus y is equal to 10. When Anna brought in 3 chairs, this becomes x plus 3 equals 10. To solve for the value of x, we add negative 3 to both sides of the equation by APE, or the addition property of equality. And we will get x equals 7. Therefore, Ben brought in 7 chairs. Now, when Ben brought in 4 chairs, our equation becomes 4 plus y equals 10. So we solve for the value of y. By APE, we add negative 4 on both sides, which will give us a result of y equals 6. We now know that Anna brought in 6 chairs. What if Ben brought in 9 chairs? The equation will be 9 plus y equals 10. Again, by APE, we solve for the value of y, which is y equals 1. Therefore, we now know that Anna brought 1 chair. Knowing that someone is there to help you makes the task seem light. And going back to the equation that we used, x plus y equals 10, what can you observe? There are 2 variables, x and y. Let's check each term that has a variable. How many variables are there? They have 1 variable on each term. How about the exponents of the terms with variables? They don't have a visible exponent, so we say that their exponent is 1. This kind of equation is called a linear equation. So, if we have a, b, and c that are real numbers, where a and b are not both equal to 0, then ax plus by equals c is called a linear equation in 2 variables. A and b are the coefficients of the variables x and y, respectively, while the number c is the constant. A linear equation written in the form ax plus by equals c is said to be in standard form. Let us try some examples. Determine if the equation is a linear equation in 2 variables. Then write it in its standard form. Let's have this given. 4y equals 6 minus 5x. There are 2 variables whose coefficients are not both 0 at the same time. And it is of degree 1 since the variables used has the highest exponent of 1. This is a linear equation. Let's write this in standard form. By the additive inverse property and the addition property of equality, we will have 4y plus 5x equals 6 minus 5x plus 5x. Combining like terms, we will have 4y plus 5x equals 6. And finally, to get the standard form, we apply the commutative property of addition. Therefore, we have 5x plus 4y equals 6, which is now written in standard form, where a equals 5, b is equal to 4, and c equals 6. Were you able to follow that? As you can see, we use the necessary properties to manipulate the equation. Let's have another one. The equation is 3 plus x is equal to 12y. Is this a linear equation in two variables? Yes, it is. Now, is this in standard form? No, but we may manipulate the equation to get its standard form. We want the x term and the y term to be on the same side of the equation, while the constant term on the other side. Applying the additive inverse property and the addition property of equality, we will have the new equation 3 plus x minus 3 minus 12y equals 12y minus 3 minus 12y. Simplifying this, we will have x minus 12y is equal to negative 3, which is now the standard form of 3 plus x equals 12y. The solution of a linear equation in two variables is the set of ordered pairs satisfying the equation. So let us find some solutions to the equation x minus 2y equals 6. Let us find the value of y when x is equal to 4. By the substitution property, the equation x minus 2y equals 6 becomes 4 minus 2y equals 6. Then we apply APE, or the addition property of equality, since we want to isolate the variable y on one side of the equation. So we will have 4 minus 2y minus 4 equals 6 minus 4. By simplifying, this gives us negative 2y equals 2. We want the coefficient of y to be equal to 1. Therefore, by the multiplication property of equality, we multiply negative 1/2 to both sides of the equation. Then we simplify, and we will get y equal to negative 1. Therefore, in the linear equation, when x equals 4, we will have y equal to negative 1. How about the value of x when y is equal to negative 2? By the substitution property again, the equation that we will have, x minus 2y equals 6, becomes x minus 2 times negative 2 equals 6. By simplifying, this gives us x plus 4 equals 6. We apply the addition property of equality since we want to isolate the variable x on one side of the equation. So we will have x plus 4 minus 4 equals 6 minus 4. By simplifying, this gives us x equals 2. Therefore, in this linear equation, x equals 2 when y equals negative 2. Now, what is the value of y when x equals 8? Again, by substitution, our equation will become 8 minus 2y equals 6. Applying APE, we add negative 8 on both sides to isolate negative 2y on one side of the equation. So, we will have 8 minus 2y minus 8 is equal to 6 minus 8. Simplifying this gives us negative 2y equals negative 2, but the coefficient of y is not yet 1. By the inverse property of multiplication and the multiplication property of equality, we multiply negative 1/2 to both sides of the equation. And finally, if we simplify this, we have y equals 1. Therefore, when x equals 8, we will have y equals 1. We were able to find 3 solutions to the linear equation x minus 2y equals 6. We write them as ordered pairs, and these are 4, negative 1, 2, negative 2, and 8, 1. Do you still remember ordered pairs? When we have ordered pairs, we know the coordinates of the points. But where do we plot these points? We will use the rectangular coordinate system. Let's recall a rectangular coordinate system. It is based on a plane with 2 lines intersecting perpendicularly, called axes. What do we call the horizontal axis? It is called the x-axis. How about the vertical axis? It is called y-axis. These axes intersected at a point that we call origin, where the value of x and y are both 0. Looking at the x-axis starting from the origin, moving to the right, the number increases going to positive infinity. And starting from the origin moving to the left, decreases the number going to negative infinity. How about for the y-axis? Starting from the origin, moving upward, the number increases. And moving downward from the origin, the number decreases. Since the axes intersected perpendicularly, the plane is divided into 4 sections. Quadrant 1, where lies the points with both positive x and y values. Quadrant 2 is where points with negative x value and the positive y value. When both x and y coordinates are negative, they will be in quadrant 3. And in quadrant 4 are the points with coordinates with positive x value and the negative y value. Given an ordered pair, the x coordinate tells us how many units to move horizontally. Positive x coordinate means move to the right, and the negative x coordinate means move to the left. Then the y coordinate tells us how many units to move vertically upward for a positive y coordinate and downward for a negative y coordinate. Now let us plot the ordered pairs 4, negative 1, 2, negative 2, and 8, 1 that we identified as solutions to the linear equation x minus 2y equals 6. We will plot these ordered pairs in one rectangular coordinate system. So let's do it one by one. The first ordered pair that we have is 4, negative 1. The x value is a positive 4. This means that from the origin, the point is located 4 units to the right. Next, we are given a y value of negative 1. This informs us the point can be located 1 unit downward. Starting from the origin, we locate 4 units to the right, then 1 unit downward. We have now located the point 4, negative 1. Next is 2, negative 2. The x value is positive 2. This means that from the origin, the point is located 2 units to the right. Next, we are given a y value of negative 2. And this informs us that the point can be located 2 units downward. Again, starting from the origin, we locate 2 units to the right, then 2 units downward. And there we have the point 2, negative 2. Then the last point, the third one, is 8, 1. So from the origin, we will have 8 units to the right and 1 unit upward. Now that we have all 3 of the points in one rectangular coordinate system, can you see what happens if we connect them all? If we connect these 3 points, we will be able to draw a line. Do you still remember lines? A line is a one-dimensional figure extending infinitely in opposite directions. Linear equations have an infinite number of solutions, and it would be very hard to list all possible solutions. But we can represent it by graphing. From the name itself, linear, graphing the solution would form a straight line. Looking back at the equation x minus 2y equals 6, we needed at least 2 points to draw the line representing its solutions. Observe that aside from the 3 points that we plotted, a line is composed of infinitely many points. And all points that lie on the line are solutions to the given linear equation. Let's try some points. We have here point 0, negative 3, which lies on the line. So let's check if it is a solution to the equation. The ordered pair 0, negative 3 means that we have x equals 0 and y equals negative 3 to be substituted in the equation. This becomes 0 minus 2 times negative 3 equals 6. By simplifying, we have 6 equals 6. Therefore, 0, negative 3 is a solution. How about the point 1, 2? This is a point not on the line. Will it still satisfy the equation? Let's check. From this, we have x equals 1 and y equals 2. By substitution, x minus 2y equals 6 becomes 1 minus 2 times 2 equals 6. Again, when we simplify, we will get negative 3 equals 6, which is a false statement. Thus, 1, 2, which is not on the line, is not a solution to the linear equation. Again, all the points on the line are solutions to the linear equation being represented. Let's have another equation. Write y equals 4x minus 12 in standard form, then graph its solution. We want to arrange the x term and y term on one side together. So by the addition property of equality, we add negative 4x on both sides of the equation. And by simplifying, we will have negative 4x plus y equals negative 12, which is now the standard form of the equation. But conventionally, we write the equation in such a way that the first term is positive. So when multiplying both sides of the equation by negative 1, we can write it as 4x minus y equals 12. We know that the graph of this linear equation is a line. To graph the solution, recall that we need at least 2 points to draw a line. The easier points that we can solve for are points where x equals 0 and y is equal to 0. Why is it? Because 0 values would mean less numerical values to calculate. So when x equals 0, by substitution, 4x minus y equals 12 becomes 4 times 0 minus y equals 12. This simply gives us the value negative y equals 12, or y equals negative 12. Let's find another solution by setting y equal to 0. By substitution, we will have 4x minus y equals 12, which will become 4x minus 0 equals 12. And this will give us an equation 4x equals 12, which we still need to apply multiplication property of equality to solve for the value of x. So multiplying 1/4 on both sides of the equation, the resulting value is x is equal to 3. Therefore, another solution is the point 3, 0. Then we plot these points 0, -12 and 3, 0. 0, -12 means we don't have a horizontal movement. So let's proceed to 12 units downward, since the y value is -12. 3, 0 means we have 3 units going to the right, but no vertical movement after that. Then finally, we connect these 2 points. Then that is the representation of the solutions to the equation 4x minus y equals 12. What can you observe with the solutions that we got? 0, -12 is on the y-axis. And this is what we call the y-intercept, where the x value is 0. Thus, this point is on the y-axis, while 3, 0 is on the x-axis. So we call this the x-intercept, where y value is 0. When the graph intersects the axis, these points of intersection are called intercepts. Next, what if the equation is x equals 5? Is this a linear equation? Yes, we call this a linear equation in one variable, since it is of degree 1 with one variable. This equation can be expressed as x plus 0y equals 5 and has solutions where any value of y, the value of x, remains to be equal to 5. So how does the graph of this look like? Since for any value of y, the value of x is 5, the graph of its solution forms a vertical line. How about the equation y equals 5? It is still a linear equation in one variable. In this case, the equation has solutions where y is 5 for any value of x. Since it can also be written as 0x plus y equals 5. So what do you think is the graph of its solution? Since for any value of x, the value of y remains 5, so the graph of its solution forms a horizontal line. If you find this lesson quite difficult, you may review your grade 7 lessons in evaluating algebraic expressions and solving linear equations. You may also visit the official YouTube channel of DepEd TV to catch up, go back, and relearn our topics. This is Teacher Joshua reminding you to practice, 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 and do it with a positive attitude and a smile on your face.